So in part C, we are given this dot. We need to draw and label forces, not its components, that are exerted on the block at the instant it is at point C. So at point C, it is over here, and so what we see is that obviously we'll have the gravitational force acting on it. We can represent it as Fg. And we will have another force. It is in contact with the loop. Therefore, it will have a force that is exerted by the loop onto the block, which will be the normal force, also pointing downwards as it is normal to the surface. And these are the two only forces that we need to represent. And then in part 2, we need to explain why a student claiming that 4r is the minimum height of point A, such that it can slide through point C without losing contact. We need to explain why this is incorrect. Well, what we need to see is that if the initial height, so h initial, was equal to 4r, then that would mean that the speed at C would be equal to 0, because according to energy conservation, the energy has to be conserved. Therefore, at point A and point C, it would have the same potential energy. And at point A, it has 0 kinetic energy. Therefore, at point C, it will also have to have 0 kinetic energy. And if the speed at C is 0, then it loses contact. And therefore, it is incorrect.